Okay, so this is just a little quick video I'm recording to go along with our PERC poster. And I'm going to talk about student epistemologies, particularly growth in student epistemologies and project-based learning courses. And I'm Duda. I'm an associate professor of physics at Creighton University. And this work is in conjunction with my grad student, Christina Ward, who's in the physics and education departments. Okay, so in terms of studying epistemologies, obviously the groundbreaking work in physics was done by David Hammer, who set up these kind of epistemological dimensions for physics students. I think that upper division students, juniors, seniors, graduate students, kind of have these first two dimensions kind of, have moved more towards the expert end of the spectrum. But I think what our work shows, and I think people recognize, is that these students still have issues with kind of these transmissionist ideas, sort of this idea that physics is learned through authority, and also this innate versus effort continuum. So we're going to talk about that, particularly in the context of project-based learning courses. So I want to talk about the project-based learning course that I teach at Creighton University, which is a quantum mechanics course. So it's a very different way of teaching quantum mechanics. And kind of the motivation for me was, obviously, we've known for a long time, PER and cognitive science research has shown the need for active learning, right? The groundbreaking Hague study has really demonstrated this. So active engagement strategies really seem to increase student learning. But the question is, are traditional approaches radical enough? So in other words, most courses are still lecture-based with some active engagement techniques thrown in, but can we go to a more completely active-based? And that's kind of project-based learning. So to give you a 30-second rundown on project-based learning, so it's a sort of super active engagement, sort of active engagement on a steroid strategy. So learning is really centered around projects or problems. So these problems are complex, real-world. Students don't have all the information they need to go out and they need to find these things, make assumptions, do calculations, search for outside information. Work in teams is kind of teamwork is very important to this. Active connected learning. And my role, faculty role, is really that of a guide and mentor. So the context I'm talking about here is really this is junior, senior, kind of one semester quantum mechanics course. And I'm in a relatively small kind of liberal arts institution, so we only have 6 to 10 students per semester. And I've been doing it this way since 2011, right? So I've got 3 years of, or 3 semesters worth of data at this point. So typical quantum mechanics topics. Now, the course is structured in this very sort of radical project-based way. There's no lectures. Projects really introduce and kind of motivate the learning in each module. So kind of thinking about problems. So why is energy quantized? That's kind of a big issue. How do systems evolve in time? What is spin? What happens in 3 dimensions? So these projects that we can talk about, you see on my poster, really kind of set and motivate the stage. And then students receive these kind of weekly work packets that provide scaffolding, homework, literature, examples, those types of things, reading exercises. Okay, so there's no lectures, so students are really expected to set their own pace, utilize class time, plan for due dates. A lot of things are very flexible for the students. They're allowed to do kind of whatever they need to do. All right, now one of the reasons why I'm really interested in project-based learning is that one of the key claims of project-based learning pedagogy is that it really increases students' self-directed learning skills and self-regulated learning skills. And you read those are right here, but the basic idea is that these are exactly the type of skills we want to be kind of inculcating in our physics students. So to what extent do these things really show up and are exhibited by students in project-based learning courses? That's one of the things we want to look at. So, all right. So in terms of data gathering, as I said, you can come, obviously look at the poster, come talk to me or my grad student Christina anytime during the PERC conference. But we did a lot of data gathering, and that was basically students performed reflections. So we have a whole other poster at PERC about reflections in project-based learning courses. But they wrote about their initial goals for the course. They did end-of-project reflections. They did post-lecture tutorial self-assessments. They did team assessments. They did end-of-semester reflections. And then we also did a series of focus groups and student interviews. So we gathered quite a bit of data looking for kind of student epistemological growth. Did they feel more like real physicists? Did they feel like they grew as scientists? Did they move on this continuum of transmissionist versus constructivist? And just to give you a quick summary of the results, I think I'd really encourage you to read the paper that hopefully comes out in PERC Proceedings. But even though we still see evidence of this transmissionist attitudes, even at this junior-senior physics major level, I think you'd see it in grad students as well, the project-based learning courses really do seem to help with this, right? There seems to be quite a bit of student growth that comes out of this. So they feel more prepared to take charge of their own learning, be active learners. They feel not only do they master content area, but they feel like they've matured as scientists and physicists as well. And they feel more confident to confront these complicated real-world problems in physics that we're seeing them. So you do see some really interesting, if you read the paper, there's really interesting student kind of quotes coming out of there talking about their sort of initially transmissionist attitudes and kind of how they perceive physics to be and then kind of the maturing process that goes on after taking this project-based learning course. So as I said, please come up and talk to us anytime at the conference or email me, Creighton University, Duda, and I hope to see you at PERC.